15C number 1. Statisticians prefer large samples. Describe briefly the effect of increasing the size of a sample or the number of subjects in an experiment on each of the following. So you have the three options. You're either selecting if it increases, decreases, or is unaffected. Letter A says the margin of error of a 95% confidence interval. Alright, so if we're increasing size n, let's take a look at the formula. If we increase size n right here, so this is n, and n divides the sigma, right? The standard deviation. If we just took just this part, because this is all really we're looking at, just the margin of error. What we know is that z star is equal to 1.96, I believe. Let's verify that. At 95%, yeah, 1.96. So going back to it, so z is 1.96. So what you're doing is you're multiplying 1.96 to sigma, and then the square root of n is actually divided to the whole thing, right? So what we're looking at is if this n goes up, increases, what happens to our margin of error? Well, we know from from arithmetic or from algebra that if we divide by a really large number, the whole thing is going to be a really small number. So if you divide 1 divided by 100, that's a really small number. 1 divided by 1,000 is an even smaller number. So as your n increases, your whole margin of error, this whole thing, it decreases. So again, dividing by a really big number reduces your margin of error. So let's go look back. The margin of error of a 95% confidence interval, again, if your n increases, your whole margin of error decreases. So I hope that makes sense. You increase the denominator, divide by a bigger number, so your whole margin of error gets smaller. The second one, the p-value of a test when the null, h null, is false, and all facts about the population remain unchanged as n increases. So the p-value, to calculate p-value, we're using this formula right here, z is equal to x bar minus mu. So again, we're looking at n, so n is increasing, it's really big. So again, you're dividing sigma by square root of n. So as n becomes bigger, you're dividing by a bigger number, so sigma becomes smaller. So this whole denominator gets smaller if you're dividing by a bigger n. So if you're dividing with a really small number, right? Let me write that down actually. So let me just write down the denominator part. Sorry, so sigma divided by the square root of n. So this goes up, so the whole thing becomes smaller, right? Because you're divided by a bigger number. So if this whole thing is small, what you're doing is you're dividing x bar minus mu to something small. So if this is being divided to something small, then basically you can think of it as like 5 divided by 1, right? Or 5 divided by 1/2. So you're dividing by something small, you're going to have a big number. And remember, if we have a big z, the higher you get with our z value, so check this out. Z only goes up to actually at 3.4. So if we have a really high z, like 5 or 7, it corresponds to a really high percentage. But again, the p-value is the right side, or the left side of that. So going back to it, that means if this is big, we're going to have a really small p-value, right? Because this corresponds to a really high percentage, and we're going 1 minus that high percentage, so it's a big number. So that means our p-value, going back to the question, should be decreasing also if we increase n. And then the last part, you should ignore this because we don't teach you power of a test. So the answer for that is actually 1. I don't know why it's there, but we apologize that it confuses you. It shouldn't be there because we don't teach it.